My name is Abdur, and today we'll look at a theorem of circle. This theorem says that the length of tangents drawn from an external point to a circle are equal. Okay. Now we will look at how this can be derived or how this can be proved right. Okay. So we have drawn a diagram. If you look at the diagram, there is external point C to the circle with center O, right? And there are two tangents which are CA and CB touching at points A and B respectively. Okay. Now, if you read the theorem is saying that the lengths of tangents drawn from an external point to a circle are equal. My external point is C, my tangents are CA and CB. So, if I read the theorem and look at the diagram, I say that CA should be equal to CB. Alright? Now, my theorem is saying that CA is equal to CB. So, I need to prove that CA is equal to CB. Now, let's look at the diagram. I need the diagram. If I look at the diagram, I say that I need to prove that this CA is equals to this CB. Okay. To prove CA is equals to CB, if you see there are two triangles CAO, right? And then there is another triangle CBO. If I prove these two triangles are congruent to each other, I can say that CB is equals to CA. Alright, and I'll be able to prove this theorem. That this theorem holds right. Okay? Let's do that. So, we are proving that these two triangles are congruent to each other. Okay? Now, OA is equals to OB for obvious reason that they are radii to same circle. Okay? The other thing in these two triangles are OC. Since OC is contributing in both the triangles, they are side of both the triangles, so they are common. So I can say that they are equal to each other, right? Now the other thing is that this is 90 degree, and that OBC OBC is equals to angle OAC, right? As we know that when you draw a tangent and it is perpendicular to the radius which is passing through the point of contact. Okay. Now we can say that triangle COA is congruent to triangle COB. Alright? By RHS. Assuming that you guys know how to prove congruency, I'm going ahead. Okay? Now I can say that side CA is equal to side CB. Alright? So this is how we prove this. Okay? Now we'll look at. Alright, let's solve a problem using the theorem that we just have learned. Okay? So the problem says that two tangents TP and TQ, two tangents TP and TQ drawn to a circle with center O from external point T. Okay? So this is what the initial scenario is given. Now we need to prove that. Further, the problem is saying that we need to prove that angle PTQ is two times the angle OPQ. Okay, this angle, this particular angle. Okay. Now, let's say this angle is X. This is this angle. This angle is QPT. Alright? QPT is equals to X. Angle QPT is equals to X, I am assuming. Now, we know that the theorem that just we have looked at, we know that side TQ is equal to side TP. Alright. So if this this particular triangle TPQ becomes an isosceles triangle, and these two particular angles will be equal to each other. So when I assume that QPT is equal to X, I know that then my angle TQP will also be is equal to X. Okay. Now look at triangle. Now look at triangle PTQ. Okay. This angle plus this angle plus this angle should be equals to 90 degree. Okay. So X plus X is equal plus angle T should be equals to 180 degree. Alright. Okay. Now going ahead, T is equals to 180 degree minus 2x. Alright. Now this, let's assume that this angle is y. Now we also know that x plus y is equals to 90 degree. Alright. Now we will replace x from there. Okay. X is equals to here 90 degree minus y. Alright. Let's replace it. T is equals to 180 degree minus 2 times, we are placing it here, 2 times 90 degree minus y. Alright. Okay. Now T is equals to 180 degree minus 180 degree. Okay. Plus 2y. Okay. I'm sorry, it's not clear. Okay. This goes off. Okay. Now T is equals to 2y. That's what we have proved. T is which angle? This particular angle, which is PTQ. Y is which angle? This particular angle, which is OPQ.